Hello students, welcome back again to the mathematics class of class 8. In the previous class, I had explained you about the squares and the methods to find the square roots with the help of prime factorization method and with the help of long division method. Today, I will explain you the property of the square numbers. What is the first property, students, of a square number? That any square number can never have the digits 2, 3, 7 or 8 at its unit place. Let's see what is the property. The first property is that any square number can never have the digits 2, 3, 7 or 8 at its unit place. So let's see an example. 2, 4, 5, 3 and 7. The digit at the unit place is 7. So we can simply say that 24,537 is not a perfect square. Similarly, take one more example. If the number is 1, 2, 3, 4, 2. We can easily say that the digit at the unit place is 2. So this number, that is 12,342, is not a perfect square. The related property with this is that is the second property, that the digits other than 2, 3, 7 or 8, those are 0, 1, 4, 5, 6 or 9. If the digits 0, 1, 4, 5, 6 or 9 are the unit place of any number, then it may or may not be possible that the number is a perfect square. Let's see few examples, students. 81. What is the digit at the unit place? It is 81, and 81 is the square of 9. Similarly, students, if we take one more example, that is 21, and the digit at the unit place is again 1, but it is not a perfect square, isn't it? Similarly, 25 is a perfect square of 5 because the digit at the unit place is 5. Similarly, a number is 45 and the digit at the unit place is 5. So it is not a perfect square of any number. So we can say if the digits at the unit place is 0, 1, 4, 5, 6 or 9, then may or may not be that number is a perfect square. Now see, the next property of the square number is that number of zeros at the end of a square number is always even. That is, take one example. Suppose, how many zeros are there? 1, 2, 3, 4. So it is a square of, students, 9 9s 81, 0, 0. This is a square of 81. Similarly, take one more example. How many zeros are there, students, at the end of this number? 1, 2, 3. And this is 9 9s are 81. But here are 3 zeros, so it is not a perfect square of any number. Next property is, students, that the square of any even number is always even and the square of any odd number is always odd. See, the square of 2 is 4, square of 6 is 36, which is uneven. You can take few more examples if you want to take. The square of 8, which is uneven, is even. Similarly, the square of odd number, that is 3 is an odd number, and the square of an odd number is 9, which is an odd. Square of odd number, that is 5, is 25, which is also an odd number. So the square of even number is an even and the square of odd number is odd. Next property is, students, the square of any natural number other than 1 is either the multiple of 4 or exceeds the multiple of 4 by 1. Let's see how. Next, that is the fourth property is, students, that suppose square of 2 which is equals to 4, and 4 is the multiple of 4. Next is 3 square, which is 9. 4 into 2 exceed the multiple of 4 by 1. 4 square is 16. You can easily write 4 into 4 plus 4 into 16. 5 square, students, 25, which is 4 into 6, the 24, plus exceeds the multiple of 4 by 1. 6 square is, students, 36. 4 into 9, which is a multiple of 4. 7 square is 49. 4 12 48 exceeds the multiple of 4 by 1. So we can easily say that the square of any natural number other than 1 is either the multiple of 4 or exceeds the multiple of 4 by 1. Next property is, students, suppose if n is any natural number, then the sum of first n odd natural numbers is equals to n square. Let's see how. First n odd natural number, suppose if we are taking 6 or 7 n odd natural numbers, that is 1. What is the next odd natural number? 3. We have to take only odd numbers, students, and consecutively 1 3 5 7 9 11. Suppose I have taken 1 2 3 4 5 6. So what is the n here, students? 6, because our definition says n odd natural numbers. So the sum of this, students, is equals to, I have already told you, n square, which is equals to, what is n here? 6 square, which is equals to 36. Now see the, students, next property. The difference of the squares of two consecutive natural numbers is equal to their sum. Let's see how. Suppose if n is any natural number. What is n here? N is any natural number. Then we can easily say that n plus 1 square minus n square is equals to n plus 1, that is the first natural number, plus n. See example. Suppose 5 square minus 4 square is equals to 25 minus 16 is equals to 9. You can directly write it as is equals to 5 plus 4 is equals to 9. Take another example. Suppose 7 square minus 6 square is this. You can directly write it 7 plus 6 is equals to 13. If you want to check this, students, you can check it also. What is 7 square? 49 minus and 6 square is 36. 9 minus 6 is 3 and 4 minus 3 is 1. So you can directly write it like this, that the difference of the square of the two consecutive natural numbers is equal to the sum of those numbers. Now, students, the next topic is Pythagorean triplet. Let us suppose m, n and p are the three natural numbers. Then if p square is equals to m square plus n square, then the triplet, that is p, or you can say in the sequence m, n and p, is said to be the Pythagorean triplet. It is the same, students, as we have already read in Pythagoras theorem, that the longest side, that is means the hypotenuse, the square of the hypotenuse is equals to the sum of the square of the other two sides, that is base square and perpendicular square. Similarly here students, the biggest number, the square of the biggest number is equal to the sum of the square of the other two numbers. And the Pythagorean triplet students is, suppose m is any natural number greater than 1, then 2m, m square minus 1 and m square plus 1. This is the set of Pythagorean triplet. Suppose if we take m is equals to 2, m must be greater than 1 students. So if we write 2 in place of m, we will get 2 into 2 comma m square minus 1, that is 2 square minus 1 comma m square plus 1, that is 2 square plus 1. So we will get the prime triplet, that is 4 comma 4 minus 1 is 3 comma 4 plus 1 is 5. So we can say a triplet 4 3 5 is a Pythagorean triplet. If you want to check your answer, then you can check it also. 3 4 5. This was the triplet students. The biggest one is 5. So the square of the biggest number must be equal to the sum of the square of the other two smaller numbers. That is 9 plus 16 is equals to 25. This is 25 is equals to 25. That is left hand side equals to right hand side. Now student, let's see the first question from the learning check 3.2. The first question from in the book is students, find the square root of 7.1824. Okay, you have to find the square root of this number students. So you will make the pair of numbers from right hand side, and using long division method we will find the square root of this number. And we will first read the table in terms of square, like 2 2 is 4, 3 3 is 9, 4 4 is 16, 5 5 is 25. So 3 3 is 9 is more than 7, so we will read till 2 2 is 4 and 7 minus 4 is 3, and again we will add whatever the digit at the unit place, we will add the same number for the next step. So that it is single digit and the digit is 2, so you will write 4. And now a decimal is there, you will write down the decimal, isn't it students? And we'll note down the pair, that is 1 8, but don't write the decimal here. Now how many times will it go? Suppose 6 times. You will again read the table in terms of square. 6 is a 36, but not here. You will write the number at the tens place as it is. 6 is a 36, 4 3 is carry, 6 4 is 24 plus 3 is 27. So you will write 6 here and 6 here. Now 276. Now subtract. 8 minus 6 is 2. 11 minus 7 is 4, and there's nothing will left. You will again add the digit at the unit place. What is that? 6. So 6 6 12 and 1 carry 5. It is 52. And we'll again note down the next pair. That what is that? 24. And we'll again read the table in terms of square for the digit at the unit place, and we'll multiply rest of the number with that number. Now 5 2, suppose it will go 8 times. 8 8 is 64, 6. Always remember students that the new digit, whatever the digit we are taking at the unit place of the number, we have to multiply the whole digit with the digit we are taking here at the unit place. So 8 into 64, 8 to the 16 plus 6 is 22, 2 is carry, 8 5 the 40 and 2 is 42. So it is 4224. We will write 8 here. So you can write 7.1824, that is the square root of this is equals to 2.68. Now students, let's see the another question, that is question number 3. Question number 3 is, students, express 64 as the sum of 8 odd numbers. What you have to do, students? You have to express 64 as the sum of 8 odd numbers. You can write 8 square, and this is one of the property of the square numbers which I have already explained you, that the sum of the n odd natural numbers, consecutive n odd natural numbers, is equals to n square. So you can write n is here, students, 8. So you can write 1 plus 3 plus 5 plus 7 plus 9 plus 11. How many? 1, 2, 3, 4, 5, 6 plus 13 plus 15. 1, 2, 3, 4, 5, 6, 7, 8 is equals to 64. These are the consecutive n odd natural numbers and consecutive first n odd natural numbers. We can't start the series from 3 plus 5. You have to take always series from 1, that is the first n odd natural numbers in a consecutive manner. Similarly, students, the next question is also based on the one of the property of the square of the natural numbers, that is using the property evaluate, that is question number 4 students. See, 578 square minus 577 square. You have to find the value of this without solving, and this is one of the property of the square, that the difference of the square of two consecutive numbers is equals to the sum of these two numbers. That means you can directly find this by adding the numbers as 115 and 11. This is the answer. Let's see the next question, students. What number must be multiplied itself become? Question number 5. I will not solve each and every question for you all, but I will explain you and you will solve it on your own. 7, 2, 2, 5. The question is, what number when multiplied by itself will become this? So simply you have to find the square root, and you will start making pairs from right hand side, and that you will get 3 pairs, and will simply solve it as I have earlier explained to you. Now students, let's see the next question. What is the next question? Question number 6, which is also based on the property of the perfect square. Give reasons to show that none of the numbers given below is a perfect square. That is question number 6. 782. Students, this is not a perfect square because the digit at the unit place is 2. As I have already told you that in the first property, any number with the digit at the unit place is 2, 3, 7 or 8 can never be a perfect square. So this is the reason for this, students. B part is, students, minus 160000. The property is, if the number of zeros ending in the square of any number must be the square of a perfect of any number, but here a minus sign is there. This is the square of this. Only this much part if we see, then this is the square of 400, but a minus sign is there, and if we square the minus sign, that means we multiply minus sign by minus 1 is always plus. So a negative number can never be a perfect square. So this is again not a perfect square. This is wrong. See students, next question number 7 is a to the power 4. Question number 7 is a to the power 4, a square. It is a square into b to the power 4, the whole square root. You have to simplify this. That means you have to find this value. This is students, this will be a and this will be b square, which is equals to ab square. If you want to see one more question, then I will solve you one more for you all. The next question is 49 x square y square, and you have to find the square root of this, students. You can simply write 7 square x square y square, which is equals to 7xy. Let's see the next question, students. That is question number 8. State the number of digits in the square roots of the following squares. You have to find the number of digits only, that how many digits will be there in the square root of these given numbers 848, 241. You have to find the number of digits in the square root of this. That means if suppose this is of 1, 2, 3, 4, 5, 6 digits, so we will start making the pairs. 1 pair, 2 pair and 3 pairs. So number of pairs, that means number of bars are 3. So number of digits in the square root of this is 3. Suppose students, if the number of digits are odd, see this question. This is A and C. That is 1, 5, 1, 2, 9. And we will start making the pairs from the right hand side. That is 9, 29, 51 and 1 is alone here. In this case also, students, the number of digits in the square root of this will be 3, because the number of bars are 3. Students, one more method is there to find this number of digits in the square root of the given number. That is, if n is even, then the formula to find the number of digits in the square root of this will be n upon 2. In this case, students, what is n? N is 1, 2, 3, 4, 5, 6. That is 6 even. 6 upon 2 is 3. And similarly, if n is odd, then in this case you will simply find the number of digits in the square root of any numbers. If n is odd, you will simply add 1. 1, 2, 3, 4, 5. So n is 5 here. 5 plus 1 upon 2, which is equals to 6 upon 2 equals to 3. So the number of digits in the square root of this will again be 3. Now students, let's see the next question. Find the smallest number by which 5103 be divided. Question number 9. 5103 be divided to get a perfect square. That means you have to find the prime factors of this, students. 5103. So this number is simply divided by 3, students. 3 1 ja 3, 3 7 ja 21, 3 0 0. Again 7 plus 1 is 9. So it will again be divisible by 3 5 ja 15, 3. That is 3 5 ja 15, 20, 3 6 ja 18 and 3 7 ja 21. Again we can divide it by 3. 3 1 ja 3, 3 8 ja 24 and 3 9 ja 27. Again we can divide it by 3. 3 6 ja 18, 3 3 ja 9 and 3 2 ja 6, 3 1 ja 3, 3 7 ja 21 and 7 1 ja 7. We will start making the pairs. 1 pair, 2 pair, 3 pairs of 3 and 1 7 is alone. And our question is, by which smallest number we have to divide this to make it a perfect square. Simply 7 is alone here, so divide 5103 by 7 to make it a perfect square. That is 7 7 ja 49. Students, what will left? 2. You will again note down 0. 7 the 7 7 2 ja 14. It is 63. 7 9 ja 63. So you can say now 729 is a perfect square. That means the final answer is 7. If we will divide 5103 by 7, then whatever be the answer, that is whatever be the question, will be the perfect square. See students, the next question is find the least number which must be added to 8902. Here you have to find that least number, sorry, 8902, so that the sum becomes a perfect square. What you have to do, students, you will simply find first the square root of this number by using this method, long division method. So it will be go how many times? 9 9 ja 81. 9 minus 1 is 8, and we simply add the same digit, and that is the digit at the unit place. It will be 18, and we'll note down the next pair, that is 0 2. Now students, how many times will it go? I think 4 times. Let's check here in the rough. 4 4 is 16. 4 8 is 32, 133, 3 1 4 4 5 6 7, 736. Now 4 times 736. What will left here? 12 minus 6 is 6. 9 minus 3 is 6, and here what will left here? 66. Now students, here it is 66 in the remainder, and this is 94, and our approach is we have to add in this number, not we have to subtract, we have to add. So what will we do, students? 94 square, sorry, we will not take the square of 94, we will take the square of 95. What is the square of 95, students? Let's multiply and get the answer. 95 into 95 is 5 5 25 2, 9 5 to 45, 46 47, 9 5 to 45 4, and 9 9 to 81 plus 4 is 85. 5 7 8 9 10 11 12. This is 10. And this is 9, which is equals to 9025. A square of 95 is 9025. Write it properly. So, and the original number is this. Now subtract from the square of this to the original number 8902. That is 5 minus 2 is 3. 2 minus 0 is 2. And 10 minus 9 is 1. 8 minus, that is our final answer is 123. That means if we add 123 to this number, this will become the square of 95.